Hello there and welcome to A2 Maths from June 2018, paper 2, and here we're looking at question 11. This is a partial fractions question. So we have this partial fraction at the top and we want to find the values of A, B and C. Okay, so now let me just show you a quick shortcut for how you can get A really quickly. What you can do is you take the highest power on the numerator, that's effectively minus 6x squared. Take the highest power on the denominator, that's minus 2x squared, plus dot dot dot, maybe plus dot 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 on the bottom as well. And then if you think about it, as x tends towards infinity, what's going to happen is no matter what constant term or what x term you've got, it's these two one on the top, one on the bottom that's going to end up being the largest value of the top and the bottom. So effectively what you're going to have then is minus 6 divided by minus 2, which is just 3. So what I've done here is I've kind of taken the limit as x tends towards infinity of my fraction and I get 3. And if I do the same on the right hand side, I'll get A, so 3 is the value for A. Okay, now that only works if the top and the bottom are equal. The degree of the top and the degree of the bottom are equal, or in other words, the highest power on the top and the highest power on the bottom are the same, then you can use this cheeky little method. So I know that A is 3. Okay, let's now get started on the standard way that you do partial fractions questions. And the standard way of doing that is to multiply by x minus 3 and 1 minus 2x on both sides. So on the left I get 1 plus 11x minus 6x squared. On the right I get a, but we know a is 3, so I'll write 3 lots of, and I'm multiplying this thing onto the right hand side. Now I get x minus 3, 1 minus 2x. For b, I get b times x minus 3, 1 minus 2x over x minus 3. And for part c, it's going to be c times x minus 3, 1 minus 2x over 1 minus 2x. So I've multiplied the denominator from the left up onto the right hand side, onto all three components of the right hand side. But notice that I can do a bit of simplifying. I can cancel out the x minus 3 from the fraction there and there, and I can cancel out the 1 minus 2x from the fraction there and there. So I've actually now got something that's perfectly in one line. It doesn't have any fractions in it. And now I use the strategic values of x that will make one of these brackets equal 0. So the first value I'll use is x equals 1/2. 1/2 will make this 1 minus 2x bracket equals 0, so I'll now substitute in across the whole line x equals 1/2. So I'm going to have 1 plus 5.5 minus 6 over 4, half squared is a quarter. This is going to be equal to, well, the half is going to make this bracket equal 0, so the whole thing when it's multiplied together will just equal 0. For the second term as well, this bracket's going to turn into a 0, so it's going to be b times 0, which is just 0. And then for the last term, it's going to be c multiplied by 1/2 minus 3. Now let's work out what we've got on the left. We've got 1 plus 5.5 minus 6 over 4. So we've got 5 on the left. And on the right, we've got 1/2 minus 3, so that's minus 5 over 2, cancel out the 5's from both sides, times by minus 2 on the other side, and we have c equals minus 2. Okay, let's now do roughly the same thing for another value, strategic value of x. We'll use x equals 3 this time. That will turn this bracket here into a 0, so it's going to be 1 plus 33 minus 54, that's 6 times 9, that's 3 squared is 9. For this right hand side, when we plug in 3, this bracket here, the x minus 3 will turn into a 0, so it's going to be 0 plus 1 minus 2 times 3, that's 1 minus 6, that's minus 5b. And on the right hand side, when we plug in 3, that bracket will turn into 0, so it's just c times 0. So working out what we've got on the left hand side, we've got 1 plus 33 minus 54, that's minus 20. And on the right hand side we have minus 5b. So in total here we're going to have b equals 4. So there we are, we've worked out a, b and c. A is equal to 3, b is equal to 4, c is equal to minus 2. Okay, so there we are. Let's now move on to part B then, and part B is as we've got it from above. A is 3, B is 4, and C is minus 2. Okay, so let's now write the fraction f of x with a's, b's and c's in it. So it's going to be 3 plus 4 over x minus 3 and minus 2 over 1 minus 2x. Prove that this expression here, where x is bigger than 3, is a decreasing function. Right, okay then, so x is bigger than 3. What I'll probably want to do first, I just want to sort out this negative component here. So it's going to be 3 plus 4 over x minus 3 plus... now what I'm going to do is I'm going to factor out the negative from the bottom, so it's going to become 2x minus 1. That will cancel out the negative from here, so it's going to be 2 over 2x minus 1. Okay, so let's now explain why when x is bigger than 3, this function here is a decreasing function. Now we all know that 1 over x is a decreasing function. As x gets bigger, the value of 1 over x gets smaller and smaller and smaller. And that is what's going to happen to these two fractions here. This fraction here, 4 over x minus 3, well, as x is a number bigger than 3, then as x gets bigger, then the number on the bottom of a fraction is getting bigger, therefore this whole expression here is going to be decreasing. And the same is going to happen to the fraction on the right as well, 2 over 2x minus 1. As x is a number bigger than 3, and as x gets bigger, then the number on the bottom of the fraction is going to get bigger. 2 over something that gets bigger and bigger is also a decreasing function. 3 is just going to stay as 3, so this is going to stay constant. So now we can write ourselves a little conclusion, as we have the addition of one constant function, constant value, and two decreasing functions, and we'll need to explain why it's a decreasing function, because the denominator, because when the denominator increases, the value decreases. When x is bigger than 3. The function f of x is a decreasing function. Okay, so there we are. That's the answer to part B then. Obviously, you could have done this question, part B, as a differentiation question and differentiated the functions, but my preference is to explain things using words and sentences if you can, and if you can see a little shortcut to doing that. So there we are. That's the answer to question 11. 7 marks for that question. Let's now move on to question 12.